Welcome back, guys. Next video that we are in efficiency. So efficiency of machine. Efficiency of machine is given as MA by VR into 100%. We studied it before. Show the relation and understanding based question. What do you mean by efficiency of machine is 80%? These sort of questions will be asked during your examination, so be prepared for that. Okay. So coming to next type, it's about no machine is 100% efficient. No machine is 100% efficient. Why? Because some amount of the amount of work done in a machine is once again wasted in form of heat energy due to friction and to move parts of machine. As a result, we say that no machine is 100% efficient. Okay, so then what kind of machine is 100% efficient? It's ideal machine. Ideal machine is 100% efficient. But does that exist in nature? No, it doesn't exist in real life. Why? Because for machine to be ideal, it must be frictionless, which is impossible. Frictionless machine is impossible in our nature. We can reduce the friction, but we cannot create frictionless machine. Next one is the machine has to be massless to be ideal. But have you ever seen, have you ever measured have you ever found that mass of a simple machine is zero? Never. Have you ever seen seen hammer of 0 kg? Not possible. You have studied in matter also that every substance has mass. For the machine to be perfect, it must be frictionless and massless. Since both of these conditions are impossible in case of machine, as a result, ideal machine do not exist in real life. Okay, so this was all about MAVR and efficiency. Now coming back to the initial topic, that is lever. Lever works in a lever has a working principle. So if I draw the lever over here effort and here load, this is known as load distance. Yeah, here we have load. Here distance from fulcrum to effort is known as effort distance. It works on a principle that input work is always equal to output work. Output work during equilibrium. So what does this equilibrium means? What do you understand? Suppose if I have applied some effort, here let's say it is load and here I have applied effort, and after applying effort, this system over here, we see it is in a balanced condition. This is before applying effort, this is after applying effort. The lever comes into balanced position. This position maintained by the lever after applying effort is known as what? Balance condition or equilibrium state. So at equilibrium, input work equals to output work. This is the principle of lever. If I have to express this mathematically, input work is given by effort into effort distance is always equal to load into load distance. This is all about the principle of lever. This might be asked, my dear people, right on the working principle of lever. You always say that at equilibrium, input work equals to output work, that is effort into effort distance equals to load into load distance. And numerical based on these questions are also very much important. Along with that, MAVR and efficiency numerical are also quite important. Okay, so it will be best if you focus on all these topics. After that, moving on to types of lever, we have first class lever. First class lever. Okay, in first class lever, if this is a fulcrum over here we have load and here we have effort. During this condition, in first class lever, either effort distance can be greater than load distance, which helps to multiply force. It acts as force multiplier here. Sometime the effort distance be greater than load distance. For example, in pliers, in pliers effort distance is always greater than load distance. Next one, in case in first class lever, load distance might also be less than, load distance might be greater than effort distance over here, which helps to increase the rate of doing work. Increase rate of doing work. This occur in case of seizure and all. Okay, seizure here load distance is always greater than effort distance. It increases rate of doing work. Sometime effort distance will be equal to load distance. This occurs in case of seesaw and crowbar. Seesaw and crowbar. You find nail cutter also, it is an example of first class lever only, as fulcrum lies between load and effort. So these sort of questions might be asked. Now question will be asked, why is plier first class lever? Because you say fulcrum lies between load and effort. Why is scissor first class lever? Because fulcrum lies between load and effort. So these all things you can remember. Okay, and in first class lever, MA might be greater than 1, or MA might be less than 1, or MA might be equal to 1 also. So these all conditions are possible in first class lever. Coming to second class lever. The second class lever where load lies between fulcrum and effort. Here is fulcrum, here we have load, and here we have effort. So at this point, if you see, this is second class lever over here, a second class lever, load lies between fulcrum and effort. This is our load distance, and this is over here effort distance. In second class lever, since effort distance is always every time greater than load distance, it can never be, load distance can never be greater than effort distance. So here MA is always greater than 1. Example of second class lever, wheelbarrow, nutcracker, right? These are the base examples that we can take for second class lever, nutcracker and wheelbarrow and all those. So remember examples, okay? Example related question, applications questions might also come. So in third class lever, we have got fulcrum over here, effort we have to apply in between. Here effort is present between load and fulcrum. If you look at this point, if you analyze this context over here, if this is effort distance and this is load distance, here load distance is every time greater than effort distance. So we say third class lever helps in speeding up the work, or it increases the rate of doing work. Here MA is always less than 1. To lift this 50 Newton weight, we have to apply more effort over here, because effort distance is less than load distance. This much about the simple machine. In the next video, I will demonstrate all of these practically to you all people. Third class lever example, you can use shovel, spoon. This can act as third class lever. Even cricket bat, fire tongs, tweezer, they act as third class lever. In the coming video, I'll be showing you a practical based. These are all theoretical knowledge. We'll be studying the practical based. I'll be showing you the model of first class, second class and third class lever. This much for today. Along with this, we complete our topic simple machine. See you in the next class.